Welcome back, everybody. We are going to be talking about something called infinite limits in this video. The textbook gives us this very long, wordy definition of what an infinite limit is, and it gives us three kinds. And we do actually have three kinds, but I want to take the scariness out of this definition because there are a lot of words. So basically what an infinite limit is our y value blows up to either positive or negative infinity as our x value gets really close to this value that we have been calling a. So our y value gets either really, really big in the positive or negative direction. So if we look at our first part of this definition, it says if the values of f of x increase without bound, that means go to infinity, as the values of x approach the number a, where x is less than a, so this time we are dealing with a left-sided limit, then we can write the following. The limit as x approaches a from the left of f of x is equal to infinity. And the second part of this definition is just saying that instead of our y values getting really big in the positive direction, they are getting really big in the negative direction. So we write this limit is equal to negative infinity. So what does this look like on a graph? Well, if we were to graph this, we are approaching the x value of a from the left, and we are getting really big. So maybe this would look something like this. As x gets really close, I crossed, didn't I? Let's draw that again, because I crossed that line. As x gets really close to a, our y value blows up and gets super big. Of course, we could also have the example of if we were to get really large in the negative direction as x approaches a. Either way, this is the left-sided infinite limit. If we were to look at the same thing from the right, which is the second part, it's the same thing. We can either blow up in the positive direction or in the negative direction. The only difference here is that we are approaching x equals a from the right. So maybe this looks like this, right? As x gets really close to a from the right, our y value gets really, really big. And of course, we could do the same thing with negative infinity. And then we have something called a two-sided infinite limit. And this just means that we approach infinity from the left and from the right. So this will look something like this. We have x approaches a from the left. Our y values go to infinity. They get really big. And as x approaches a from the right, we also go towards positive infinity. And if we wanted to do this in the negative direction, it would be the same thing, just reversed. So we could go like this. That is going towards negative infinity and negative infinity in this direction as well. The most important thing, or one of the most important things to remember when we are dealing with infinite limits, is that any kind of infinite limit, left, right, positive, negative, two-sided, whatever, regardless, we say that this limit does not exist. So let's write that down. When we have an infinite limit, the limit does not exist. An infinite limit. An infinite limit. The limit does not exist. Sometimes we abbreviate does not exist as DNE for short. So any kind of infinite limit, we just say that the limit does not exist. That's because it's not approaching a particular number, right? If we think back to our previous definitions, that y value had to approach a number L. But in this case, we're not approaching a number L. We're getting really, really big. We're going to infinity. So therefore, the limit does not exist. Let's do another example here, looking at this pink graph down below, and evaluate all of these limits. So the first one is the limit as x approaches 2 from the right of f of x. So we are approaching 2 from the right side. So we are on this piece of the graph, And I see that as x approaches 2 from the right, our y value is exploding. So this is equal to infinity, which means that it does not exist. And as we approach 2 from the left, let's do it in a different color. As we approach 2 from the left, the same thing happens. Now we're on this piece, but it still gets very large as x gets really close to 2 from the left direction. So this is also equal to infinity, which means that this limit does not exist. So because in this particular example, the right-sided limit and the left-sided limit of 2 are both equal to infinity, this is considered a two-sided infinite limit. So let's look at 4 now. We want to look at the limit as x approaches 4 from the right. So here we are approaching 4 from the right. And that means we're on this quadratic piece here. And we can see that the y value looks like it is approaching 10. So this limit is 10, which does exist. That limit does exist. And then if we approach 4 from the left, we are on this piece again, which is going down towards negative infinity. Negative infinity, which means that our limit does not exist. So in the case of 4 here, this is a one-sided left infinite limit. Our right and our left limits don't agree here, which is okay, that happens, but that just means that it is a one-sided infinite limit. All right, that is it for this video.